The next question is a flywheel weighing 50 kilonewton and having radius of gyration 1 meter 1 meter loses its speed from 400 rpm to 300 rpm in 120 seconds. Calculate. The first one is the retarding torque acting on it. The second one is changing kinetic energy during above period. So first you should read the question once more. There is flywheel weighing the weight of flywheel is 50 kilonewton and having the radius of gyration, that is 1 meter. What is the radius of gyration and radius? What is the difference between the radius and radius of gyration? Actually, in theoretically it's having some different values, but practically in these cases both are same. Because what is radius? If we are considering a circle as like we can write in here, and if this is a circle, we are called this as radius. If in this case, the circular body we are calling from center to the outermost portion, that is called radius. But if it is a unshaped body or rectangular or any other type, if you are considering one axis over there, from axis this is the distance to that considering body. If this is the elemental body we are considering, so this is called radius of gyration. In this case both are same because we are considering this. If it's considering this elemental body, it will rotate as like so, it goes as circle, so both are same. So don't worry about radius. If the question gives radius of gyration or radius, both are same, almost same. Okay, then we can come to the solution. We have two questions, two cases. That is what is retarding torque acting on it, and then because it's losing its speed, it says as losing its speed. Then second one is change in kinetic energy during the above period, that is change of kinetic energy, that is Ke. The first one, the given details, that is n1, that is rotation at the first time, that is 400. Then second condition, that is n2, that is 300 rpm. Both are in rpm. Then t is equal to 120 seconds. The 120 seconds to take 400 to 300. So weight of that wheel, that is 50 into 10 power 3, that is 50 kilonewton. Now we are converting to the newton, that is 50 into 3 newton. That is K. Instead of R we are using that is K because it is a radius of gyration. That is K is equal to 1 meter. The first case 1, retarding torque, that is T is equal to I alpha. That is already we have discussed about these equations and all of the things. What is I? That is I is equal to mk square, mr square instead of the in that equation, that is mr square. Here we are using instead of r, that is k, that is mr square. So we are substituting the value of mk square here, then mk square into alpha. Then this equation, that is omega 2 equal to omega 1 plus alpha t. This already we know this equation. We are substituting the equations omega 2, here it is 300 and omega 1 is 400. We are converting that npn and that is rpm to omega, that is radian per second. So 2 pi by 60, here also 2 pi by 60. Sorry, this is plus, so I mistakenly written this plus alpha into 120. So substituting these values and calculating the value of alpha, that is this, that is negative value. Alpha is because it is retarding, and alpha, that is equal to minus 0.087 radian per second square. The second case we already discussed that is T is equal to I alpha, that is I is equal to mk square by mk square alpha. What is m? That is mass. How we can what is mass? Okay, so alpha is equal to this value, so T is equal to I alpha, then mk square alpha. Okay, then m equal to so we are converting by newton to mass, so divided by 9.81. Then T is equal to, we are substituting the values over the m, k and alpha. So we are substituting and we will get the T value. So this is a torque. Then second case 2, change in kinetic energy. The changing kinetic energy equation is half I omega 1 square minus half I omega 2 square. In the previous derivations we are using changing kinetic energy omega 2 square minus omega 1 square is there, because in that case that is a acceleration. Here it is a retardation. That's why we are using the highest initial values first and final values last, because otherwise it will be this is a small value and this is higher value, so higher value to minus lower. That's why we are providing here, because it's a change in kinetic energy. So we are substituting identify this half I is common thing. Now we are not taking outside and then rewriting the equation half I into omega 1 square minus omega 2 square. Then omega, what is omega 1? That is 2 pi n1. We are substituting and we will get the value. Then now what is omega 2? That is 2 pi n2. That n2 is 300. We are substituting the value and we will get the value. Then we are substituting these two in a change in kinetic energy equation, that is half into mk square omega 1 square minus omega 2 square. Then instead of I we are providing mk square, and then substituting the values, and then we will get the change in kinetic energy. Okay, then thank you. Then maybe the next question is, okay, we can wait for a minute. Okay, the same type of problems I skipped there, and then come to the next topic, that is plane motion of rigid body. What is rotation? A motion is a rotation. That means particle of a body moves along a concentric circle. That means this is a center. If it is a body, or if this is a body, it's a larger body. If every particle will move with a concentric center, so it moves like this one. So every particle of a body moves with the same center. That is called rotation. What is translation? Translation: all particles of the body moves along a parallel path. That means if this is a body, all particles, if these two are the particles, it will move in the same line, because it's parallel. The movement should be parallel. Here it is not parallel. One point is center, another point is not parallel. So this all the particle moves in a same line, or same parallel way. So that is called translation. So translation having two sections. The first one is rectilinear translation. Second one is curvilinear translation. From figure we can say that what is rectilinear and what is curvilinear. This is rectilinear. In this body we can consider this. These are two parallel lines. So it's a translation. So both are parallel and straight lines. So it is rectilinear. And the second case, these two lines, these 2 points is parallel. This is also parallel, but it's curved. Curved parallel lines, they are moving in a curved parallel line, so it is curvilinear translation. So this is curvilinear translation and this is rectilinear translation. Then come to the plane motion. So right now we are discussing about the rotation and translation. So in plane motion we can see these both. That is rectilinear motion, translation and rotation. Both will be there. Other way we can say neither translation nor rotation. It's not a translation. It's not a pure translation. It's not a pure rotation. It's both. That we can say plane motion have both translation and rotation. We can easily say if you take a vehicle wheel, it will rotates. The vehicle also moves, right? So that is the example over here. That is, we can consider this is a tire or wheel of a vehicle. It rotates. So it's rotated. We can consider the point A. It will move to this point, isn't it? Okay. So but this point it will rotate and it will move. That is translation. So that is called, the object will be moves forward. That is called translation. But the particle should move in a concentric circle according to concentric circle. That is rotation. So plane motion having translation and rotation both. Okay, I think you can understand things. What is plane motion and what is translation, what is rotation. Translation means it moves in a parallel way, but rotation means it's rotating, or the particle will move with a concentric circle. What is plane motion? That is, it's having both translation and the next topic is wheels rolling without slipping. That is translation. Wheels rolling without slipping means translation. translation, that is, this is the wheel with the center C, and it will, the point is having 2 points, that is A and B. It moves from here to here, so the C moves from here to here, so by rotating. So it's A rotating towards this, B rotating towards here, then it will moves from here to here. That time A is rotating to this way, and it will, B is rotating to here, so B is coming to here, A is going to there, so it will moves A to B, the position wise A to B. So it's a linear distance of traveling, that is from A to B, that is, we can call it as a SC. C means center, S means distance moving, it's movement, so we are called as a SC. S is a linear distance. So how we can identify this, how much it is? That means this distance should be same as this much, right? Because it will rotate this 2 up to here, that is, this A is going there, B is going this way, that is, B come to here. So it will move the same length of this arc length of, that is AB of arc length of AB, that is same as SC. So what is arc length? We can call it as a R theta, that is radius into include angle. That is, this, if this is a R and this is a theta, we can call this is R theta. This is radial arc length is A to B, that is R theta. So the linear distance is traveling, that is same as angular distance, that is R theta. Then this is SC equal to R theta. The next thing, velocity. Velocity of C. The C means center. Velocity of center, that is called VC. That is linear distance. That is this case is distance SC d by d theta dt of SC. That is, we can call is SCS R theta. So d R theta by dt, that is equal to R d theta by dt. D theta by dt is omega, so we can write it as Vc is equal to R omega. In the case of acceleration, C, acceleration of point C, that is AC equal to dVc by dt. Vc is R omega, that is dr omega by dt. That is, R omega means d omega by dt is alpha, so AC into R alpha. Okay, these equations we already studied, that is alpha, what is omega, as like things we are already studied in last sections. Then come to the next topic, that is instantaneous center of rotation. What is the meaning of instantaneous? Instantaneous means it's a fraction of seconds or just a second, that is called instantaneous. If the case of translation for a wheel, that is just before we are talking about that wheel, the center, it's rotating continuously, the center is rotating from one point to another, that is the motion of rotation of translation of, that is translation and rotation both ways of body at a given instant can be considered as that pure rotation of the body about that point. This point about which the body can be assumed to be rotating at the given instant is called instantaneous center of rotation. How we can say what is instant? Did you understand this thing? We can solve the previous problem, which we can explain which is the previous problem. That is this one. This point, in this case, this is the, if we are considering this body, this is the instantaneous center for that, because this body is rotating individually with this center, but it's move with according to this point, at that point it's rotating and moves to the next point. So this is the instantaneous center for at this second. The very next second it moves to this point, so instantaneous center is moves. So instantaneous centers continuously moves when it is moving, so that is called, it is instantaneous center. So it is called as instantaneous center of rotation. Okay, the velocity of this point at the given instant is 0. This point is called as instantaneous center of zero velocity. At that point, if the velocity is zero, that is called instantaneous center of zero velocity at that time. So the next thing, the locus of instantaneous center of the body goes on changing its position is called centron. If we are considering this is the instantaneous center for this second, this is the instantaneous center for next second, this is for next second, so it's moving. So according to one point it's changing, that is called centroid. It's not a centroid, it is centroid. Okay, so this is once more I talk that the locus of the instantaneous center as a body goes on changing its position is called centroid. Okay, this is the terms we want to familiar with that things, and then we can come to the problems. Okay, the next problem is a cylinder of radius 1 meter rolls without slipping along a horizontal plane AB. Its center has a uniform velocity of 20 meters per second. Find the velocities of the point D and E on the circumference of the cylinder as figure. Figure is also given here. This is a figure. So cylinder is 1 meter, radius of 1 meter. So its total is 2, diameter is 2, radius is 1 meter. Without slipping, it's not slipping. It is rotating along a horizontal plane, that is AB. Its center has a uniform velocity, that is C has a uniform velocity of 20 meter, that is moving with a 20. This point is moving with a 20 meter per second. Find the velocities of the point D and E on the circumference of the cylinder. The point D is moving through this one, E is going through this one. So what is the velocities of D and E according to this point? This is the question. So we can come to the solutions. The linear velocity of point O, this is the point O. O is 0. The linear velocity is 0. It's linear, not angular. Velocity is 0. O is 0. It is instantaneous because it is an instantaneous center. Okay. The velocity of C, that is center, is omega into OC. That is, velocity of this point is omega. What is omega? Angular velocity into this distance. So we can consider a small figure here. This is O and this is C. If C is moving according to this way, it's having an angular velocity of omega. It's just a second, just for an instantaneous instant. So this second O, so it's moving from here to here. So what is the velocity? That is omega is here. From here to here, this we have a distance that is called OC. That is a radius, right? So the VC here is equal to, this is omega into this R. Omega into R. That is, we are written here. That is VC is equal to omega into OC. That is R, radius. So we are substituting the value of 1. Then we already know that in question paper, question itself we are given what is VC. That is 20 is equal to omega into 1. Then we identify the value of omega. That is 20 radian per seconds. Okay. Then we want to calculate the velocity of point E. So similarly, V is equal to omega into OE. That is, omega is the angular velocity into OE. OE is the distance. OE. OE, what is the OE? Here it is, OE is the diameter. That is double times of radius. 20 into 2, that is 40 meter per second. Similarly, velocity of point D. VD equal to omega into that distance, that is OD. Here, this is a section, just I forgot to write this. Okay. So this is a D and this is E. We know that horizontal distance is 1, and because it's a radius, and the vertical distance is 1, that is also radius, but we don't know the diagonal or perpendicular distance from D to O. So we want to calculate that one. By Pythagoras theorem, we can calculate that is OD equal to root of OC square plus CD square. That is both are 1 because it's a circle. So 1 square plus 1 square. So that is root of 2. We are substituting the value over the VD is equal to 20 into 2. That is equal to 28 meter per second. So the question was these two, calculation of these two, that is VE 40 meter per second and VD. What's the value of VD? That is 28.28 meter per second. Then the last question of today's section. Okay, the next question was, a cylindrical roller is an contact at its top and bottom. So cylindrical roller, it's contact at its top and bottom with two conveyor belts. So it's having two conveyor belts, one cylinder roller. So it's having both conveyor belt are contact with the cylindrical roller. AB and D as shown figure. So it's detailed given in figure. If the belts run at a uniform speeds, that is 3 meter per second and 2 meter per second. So one is in 3 and one is in 2 meter per second respectively. Find the angular velocity of the roller when two cases is given. The first case, the velocities are in the same directions. That is, two belts are moving in same direction. Second one, the directions of velocities are opposite in opposite. That is the second case. That is direction of velocities of two belts are opposite in direction, moving in opposite direction. The diameter of the roller is 40 centimeter. That is also given. Okay, we can come to the first case. This is a question with a question. This is a figure with a question. Okay. So case 1. When the velocities are, so it shows one roller, cylindrical roller, two belt. There is one belt and this is one belt. Its first belt is moving. We considering the first case, that's why the first belt is moving this way, and second belt also is moving same way. So first case, the velocity of belt has 3 meter per second. Second belt having the velocity of 2 meter per second. So and then it's a name as AB and DE. Then 2 points with contact, that is P and Q. The velocity of center, that is we can call the center as C. Center, that is VC. Okay, this much details is given in the question. So come to the first case. When the velocities are in the same direction, that is as like this, both are in same direction. 3 meter per second in forward direction, and this also 2 meter per second in forward direction. So first of all, we should assume one thing, that is the instantaneous center should not be inside this section. It should be below the point Q. It may be down. So we can represent here instantaneous center. This is the point Q and this is the point P. Then we can call this as I. Okay, I written here also. Okay. So this is P, circle will be here. So the instantaneous center will be down of Q. Will be some distance from Q to I. It's in downside because it's both are same direction. Okay, the distance we are called as X. So we know the radius of that 0.4 meter because 40 centimeter it's given in question. We are converting to the meter because this is centimeter and this is also in meter. So X is below. So first of all, we calculate this velocity of here. How we can calculate? The angular velocity, that is omega into the distance from here to here, that is IP, I to P. So that is angular velocity, that is omega into IP, that is equal to, we know that velocity over there, that is 3 meter per second. So IP we can convert this from here, from the figure, that is 0.4 up to here P to Q, that is 0.4, Q to I is X. So we can call it as X plus 0.4 or 0.4 plus X, whatever it is. That is omega equal to omega into X plus 0.4, that is equal to, that is instead of IP we are providing X plus 0.4, that is equal to 3 meter per second. The second case, we are considering velocity over here, that is 2 meter per second. That is IQ, that is the distance, into omega. That is IQ into omega, that is equal to 2 meter per second. So what is IQ? That is x. So we are writing here, that is omega into x, that is equal to 2 meter per second. So we are writing, this is the first equation and this is the second equation. Then we are comparing both equations, that is 3 by 2, 1 by 2. We can provide 1 by 2, that is 3 by 2, that is equal to omega x plus omega into x plus 0.4 divided by omega into x. Omega and cancelled, and then we will get the value of x. That x will be 0.8. We after calculating, we will get the x value of x as 0.4. Then we are substituting equation 1 or 2, whichever it is easy you may feel. I providing the value for equation 2. Both are same. We can provide any equations, it's not a problem. So x is equal to 0.8 we are providing here. Then x is omega equal to x by, that is 2 divided by x, that is we will get the omega values 2.5 radian per second. This is the first case, answer of first case. That's the velocity of c. Okay, then come to the second one, case 2. Velocities are opposite direction. So velocities are opposite direction means, in the figure we can say that it may be in 3 meter per second forward direction. This 2 is in opposite, it's backward direction. This, so it's opposite direction. This is in direction, we can write this is 3 in direction and 2 in this direction. So both are opposite direction. So in this case we are considering same method, but instantaneous center, in this case instantaneous center will not be outside peak, in between PQ. This is the figure circle. We are considering the first case, the instantaneous center will be down from Q, but in this case the instantaneous center in between P and Q, that is a top and bottom, in between top and bottom. So we are showing that this is from P to Q, that is 0.4 meter or 40 centimeter. The x will be above the Q. So x, this is the instantaneous center, this is P and Q, this is I. Previous I will be here. The previous case we are considering I will be here. Then in this case I will be upside because it's opposite direction. So just note down these differences between opposite side and similar directions of contact. So omega equal to IP, that is we are considering this velocity over there, that is 3. So we know that I, that is angular velocity angular omega into this distance, that is IP, that is omega into IP, that is equal to 3. We know the value. So instead of IP we can say, 1 minute, okay, instead of IP we can say what is it is 0.4 minus this x, 0.4 minus x. So omega into 0.4 minus x equal to 3. This is equation number, we are considering this is equation number 1 in case 2. Then omega into this, for this side omega, this is, if this is omega into this IQ, that is equal to 2. Then omega into IQ equal to 2. We are considering the IQ as x. So omega into x is equal to 2. So from equation number 1 and 2, from case 2, from dividing 1 and 2, we will get 3 by 2 equal to omega into 0.4 minus x divided by omega x. Omega and cancel, and we will get the value of x. That the x value is 0.16. We can provide the x value in equation number 1 or 2, which one you can feel it is easy. Then provide x is 0.16 into omega, that is equal to 2, that is omega equal to 2 by 0.16 into, that is equal to 12.5 radian per second.